That's it. If you do those 6 steps for every compound, you will write the right formula every time. It may seem trivial, but it's repeatable and it works every time. Some people, particularly people who have had some chemistry before, can probably do steps 1 to 5 without writing the boxes and just using the tables in the back of the book. And then do step 6 without the boxes. I use the boxes because it has people who haven't had chemistry before think of things in the correct order. And if you do the things in the correct order, then you're going to get the right answer. And when we start doing balancing equations, we're going to have 4 compounds, 2 that are reacting with each other and 2 that are products. And the first step in balancing the equation is going to be to do this 4 times for each compound. The reason I don't do the lectures together, and I do this separately, is because once you've determined the formula writing is done. When we go to balance an equation, we never go back and change the formula. This piece is done. So balancing the equation is going to have one more step called balance the equation. But we never go back and change anything here, because if we change the formula, we change the compound, and then it doesn't match the question anymore. So, formula writing, completely separate from balancing the equation. And that's, I used to do the lectures together. And people would get to step 7 and go back and change the formula. So not only did they not have a balanced equation, but they didn't have the right formulas for the 4 compounds. 6 steps every time. So here's a compound. Cupric cyanide. Who's coming up to do it? Not you. Anyone? Bueller? Well, I would bring your book. You could bring your paper and bring your book, because you're going to have to look these up. You can ask the rest of the class. So I drew the boxes and I wrote the name. There's no physical state in this one. So that's 3 of 6 steps done. Yeah. And it's cupric. Yeah, so put the positives. And cyanide. So, does everybody see where that came from? Cupric, copper plus 2, Cu plus 2 is on the left-hand page in the inside back cover, in the bottom half under Latin system, because this is the Latin name for copper plus 2. And cyanide is a polyatomic anion, and it's found on the right-hand side, in the last box down, common polyatomic anions. So we're down 5 steps down. So now we're going to make sure that the charge is balanced on both sides. Yep. Yep. Okay, so cyanide is -1. We need 2 of them. We need parentheses because it's polyatomic. So I'm going to make this one. So the formula without the boxes CuCN2. Sort of the unwritten step is, once you determine it and make sure the charges are balanced, you can take away the boxes and just write the formula. Good, thank you. Oh, don't make me call names, come on. Somebody else had their hand up for the first one. I don't want to do it. I'm not smart enough to be smart for it. Bring it. This is it. This is me. So again, draw the boxes, write the name. We're not going to deal with the physical state. So we're up to looking up the symbol and the charge in the back of the book. All right, sodium is Na, and it has a charge of +1. That's a sodium ion. Now phosphate, we look up. PO4, and it has a charge of minus, no. We want to look that one up. Phosphate. Well, you have to have really good vision. PO4. The formula is PO4. That's another thing. If you have trouble, breathe. This is really important for you.
Set the eraser in the other one. Put the eraser in the one in the middle.
So, do you have something that's going to help you read this in the book? Because these numbers are tiny. Tiny. I'm talking about if you had to read phosphate ion and then read what it is, these numbers are really small. So, can you read them? Oh, well, as long as you can read them, it's good. So phosphate ion has a charge of -3. Sodium ion has a charge of +1. We need to have enough sodiums so that the net charge is 0. Right, so how many sodiums do we need? that look pretty good? Plus 3, minus 3, 0. So the formula for sodium phosphate, if we took away the boxes, would be Na3PO4. We don't have to have any parentheses around the phosphate because we only have one of them. We don't have to have parentheses around the sodium because it's monoatomic, it's not polyatomic. So that is the formula for sodium phosphate. Good job. Correct. How many more are there? Was anyone going to do it? Tin 2, so tin is SN, stannous. Nitrate is NO3. It has a -1. Okay, one tiny error, and that's that. It's not a superscript, it's a subscript. So the 2 goes down here. There you go. So, NO3, 2. And we need the parentheses because we have a polyatomic anion and we have more than one of them. So, here's the formula. How many oxygens are in one molecule of tin nitrate, tin 2 nitrate? 6. 2 times the 3. And a molecule, coffee, a molecule is the smallest unit of a compound. An atom is the smallest unit of an element. A molecule is the smallest unit of a compound. Oh no, another one. How many more? Oh, this is the last. I don't want to answer twice. All right, so there's one more. I'll do this one. So, mercurous chromate, because this is a tricky one. If I look up mercurous ion, mercury 1, mercurous, in the book, even though it's mercury 1, mercurous ion is a little bit different. So the symbol, it always comes in pairs. Even though each mercury only has a +1 charge, mercurous ion is Hg2 + 2. And that's what it says in the book, the bottom half of the left-hand page. Then if I look up chromate ion, CrO4, pretty sure it's minus. Yep. Chromate and dichromate are -2. So, +2 2 minus 2, add 0. So I'm good there. I don't have to do any multiplying other than I had to make sure I had that ion right. So the formula for mercurous chromate is Hg2CrO4. And I don't have to have parentheses because this is monoatomic. And the polyatomic doesn't need any parentheses because there's only one of them. So back when I was a child and I fell off my bike and I scraped my knee or my elbow or my shoulder or my hand, there were 2 things that Mom would put on my scrape. One was tincture of iodine, and a tincture means something mixed with alcohol. Nice. So martini is kind of, tincture of olive. I don't know. Tincture of potato. Tincture of potato. So tincture of iodine, or something called mercurochrome. Nice. Mercury compound. Nice. And the thing about mercurochrome that was better than iodine for my little scrapes is iodine burned like hell when Mom put it on from the little bottle. It just was like my hand would be on fire. So we hated that. Mercurochrome didn't burn as much. And both of them were antibacterial. Iodine is still used in hospitals. I mean, if somebody is having surgery, particularly abdominal area surgery where there's going to be an incision, they get painted up really nice with something called betadine, which is a form of iodine and several other substances in alcohol. And it makes it nice and orange. So mercurochrome, which was the tincture of mercurous chromate, was used on injuries. But of course, we have subsequently discovered how toxic mercury is. Most mercury compounds, the worst being organomercury compounds. It's what made the Mad Hatter mad in Alice in Wonderland. Was mercury poisoning. It attacks the brain. Organomercury compounds were used in some herbicides and pesticides. They're banned, but they got into our food supply. A lot of people I'd say in the last 10 to 15 years, have systematically had mercury-based fillings removed from their mouth and replaced with ceramics. The old fillings that were silver and gold weren't pure silver and gold, they were silver and gold amalgams, which means that they were mixed with mercury. So it was gold mixed with mercury, which made the gold set harder. It was harder. Pure gold or pure silver are soft metals, and eventually you would grind them down in the chewing process. So it made them harder and long-lasting. Let me say something else about that. But you're introducing mercury into your system, and that's a bad thing. So, toxic. We know all about the mercury in fish. Fish seem to accumulate mercury, particularly tuna. All not good for our health. All right. So that's the last of the fun and games, I'm afraid. All right. Now we're going to talk about the other type of molecule that we'll deal with and do formulas, called binary molecular compounds. The difference between an ionic compound and a molecular compound is that a molecular compound is not made up of an anion and cation. It's not ionic. We're dealing with binary molecular compounds, which means two elements, and they're both nonmetals. So we don't use the Bowling method or the boxes method in determining the formula. The formula is deduced directly from the name of the compound. In the compound phosphorus pentachloride, which is a binary molecular compound, there's one phosphorus and 5 chlorines. And the way we know that is because it has the prefix penta. Now on page 187 in your textbook, there's a list of the Greek prefixes, which I might have on the next slide. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, 1 to 10. Mono 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So phosphorus pentachloride has the formula PCl5. If you start writing the boxes, you are not going to find, you'll find the chloride in the back of the book, but you won't find phosphorus, and then you're going to try to figure out what it is, and you're going to get, you're like, I can't find it, it's not in the back of the book. So if you're doing a question like this on the test, and you start getting ready to say, Mr. Grayson, that's not in the back of the book. If it's not in the back of the book, it means you don't need to be using the back of the book. It means it's a binary molecular compound. Because that's what I'm going to tell you if I come over. You're going to go, it's not in the back of the book. You say, you don't need to use the back of the book. And you're going to look at me bewildered and go, how can I do it then? And I'm going to say, what's the other kind of compound that isn't an ionic compound? A binary molecular compound. So I have some examples of this for us to do, and I'll do these, because we don't have to look anything up. Silicon dioxide, sand. So what I do need to use might be the inside front cover of the book where the periodic table is. Because I do need the symbols for the elements. Silicon is Si. Oxygen with O. And I have dioxide, which means I have 2. So silicon dioxide, binary molecular compound, SiO2. Just like carbon dioxide, and if we look in the periodic table, we'll see that carbon is directly above silicon. So we'd expect it to have similar properties, physical properties and chemical properties. One of the chemical properties is how it reacts with other elements, like oxygen. So carbon dioxide, CO2, silicon dioxide, SiO2. I suspect that germanium dioxide, which and amine being directly under silicon would be GeO2. Very common. Sulfur trioxide. Two nonmetals again, oxygen, sulfur. Sulfur is S, oxygen is O, tri is 3. S, O, 3. Sulfur trioxide. Much easier than the 6 steps. Really find the symbol and read the prefix. Carbon tetrafluoride. I think yesterday I said carbon tetrachloride was a dry cleaning solution. Carbon tetrafluoride is, what, anybody know what
You change, it change.
I tapped the screen. Shame on me. Carbon is C, fluorine is F, and tetra means 4. Carbon tetrafluoride CF4. This is what DuPont makes Teflon out of. Teflon is a polymer that uses carbon tetrafluoride as a starting material. I'm pretty sure I remember that. I won't ask you though. All right. All right. So here's one that's a little different. 'Cause up until now, each of the ones I gave you basically had just a single atom of the first element. So here's one, dinitrogen tetraoxide. Nitrogen, oxygen, and O. But this time we have a prefix in the first one as well. So di is 2. Tetra is 4, so dinitrogen, N2, tetroxide, O4, N2, O4. So in the second exam, your second exam, one of the things you can expect with formulas and names is a grid. And the grid will have stock name, Latin name, formula. And so on. In each instance, one of these 3 blanks will be filled in, and you have to write in the other 2. So if I had FeCl2 here, you would say, you would write the stock name is iron 2 chloride. The Latin name is ferrous